notice two items directly in front of you. These two items have two things in common. One of the things is, well, they're antiques. We don't really use them today to provide heat and light. And I've given you the answer to the second thing they have in common. They both utilize heat and light for their main purpose. Now, today we're going to try to find out what is the relationship between heat and light. How do we produce heat? Rub two sticks together, or bow and a spindle, or even just light a match. Let's try that and see if we can produce heat. Now, with our match being lit and our alcohol torch being lit, we find out that not only is heat produced, but also we are producing light. So these two items, heat and light, have something in common. In fact, if I'd go a step further and take a piece of iron wire and have this iron wire placed right into the flame, we could see that after a while we would find the wire gets quite hot and eventually would turn red hot, possibly white hot, so that we could produce light through heat by allowing this wire to heat up and give off light. Now, we've used the flame. How else can we produce heat? Well, a simple way is to use an electrical source of energy. Here I've taken one strand of a many-stranded wire, copper wire, many strands. I've just taken out one strand, and I'm going to connect this strand across the terminals of my battery. Now, I would not recommend that you do this too often. It ruins the battery, and it has another safety factor, a safety factor which you can tell just by watching this demonstration. I'm going to wrap absorbent cotton around the wire. This absorbent cotton will help point up the fact that we can produce heat electrically. Here we go. Wrap the wire, and with a pair of pliers, I will place this wire against the other terminal. Let's just watch and see what happens. Notice the cotton. There is sufficient heat generated by this wire to burn the cotton and even melt the wire. The wire is melted right in half. So that we see we have produced heat electrically just by using our battery. Now, that's the reason I say we don't do this too often. If the heat is sufficient to melt a wire, I guarantee it's sufficient to give a burn on the finger. So we don't hold the wire with our hands, we hold it with a pair of pliers, and we only do it once in a while as a classroom demonstration experiment. Now, do we use this type of heat? I don't know about you, but I do. I use it right here in something like this immersion heater. You ever seen one of these heaters? Place it in the water, and we plug it in. Now we plug it in, there is a wire within the heater, not the outside itself, but this wire gets very hot, and this heat is transferred to the water. Now if we watch the water very carefully around the immersion heater, we can see that it starts to bubble and boil. And I could use this immersion heater to make tea or coffee or even sterilize instruments if I were doing some form of operation, if I were a doctor. Now here we're producing heat electrically. Quite a good amount of heat, a large quantity. Quantity of heat sufficient to really boil water. Now, where else do we use heat or electricity to produce heat? One of the more common items is the heating pad. You may have a heating pad at home, and you've always seen it this way, you know, the whole thing nice and closed. Mother says don't put pins into it, and it says on the label, don't get it wet. Well, the reason that they tell you not to allow a heating pad to get wet or not to put pins in it is this. Now, I've opened this pad, and we find out that the heating pad itself is actually a large coil of wire. Now, this coil of wire is heated by electricity when it's plugged in. Now, it doesn't get as hot as the immersion heater. We're not using this to cook us. But it does give off a standard amount of heat, an amount of heat which I guess the doctors have figured out would be a suitable amount for the human body to take. So the heating pad is another device which gives us heat electrically. Now, most common item, I would guess, as far as heat is concerned, electrical heat, is the stove, the electric stove. Here we have a coil of wire which has been placed in a ceramic or baked clay holder. The reason we use the baked clay is that it will not melt when this coil is allowed to heat. When the electric stove is plugged in, the coil gets quite hot, gives off heat, and if we would put a pot or any other object upon the top of the stove, we could cook. So here is a typical everyday modern usage of electrically produced heat. Let's look at an interesting phenomenon. You know what a phenomenon is? It's something that happens scientifically. Now, here we have an old type toaster. Doesn't mean that it's not a very suitable and workable type of toaster. It's just not an automatic. It doesn't pop bread up or doesn't pop bread down. It has within it a set of heating coils. Now, these heating coils, when plugged in, will heat and do one other thing. Let's watch the coils very closely. I'm going to put a piece of cardboard over the top so we can take all the shadows or all the bright light off the coils, and I'm going to plug in the toaster. Let's just watch the toaster. We are not only producing heat, but we're producing two other things. One of the things that we're producing is light. You notice the way those coils have heated up? In fact, I'm going to unplug it now. Just watch. See? Coils have cooled down. No source of heat, no source of light. But we've produced heat as well as light with our toaster. Now remember I said we produced two other things besides heat? Yes, we produce light and, let's see, we produce toast also. So that our toaster produces heat and light. Now we don't sit around really reading by our toaster. We might get a small amount of light from it, but we don't depend upon the toaster for light. Just as we don't depend upon our electric iron for light. And you say, I've never really seen light come out of an electric iron. Well, it doesn't really escape. But if we take common electric iron, here I have a small type. We take an electric iron and plug it in. You know, Mother takes it and sort of wets her finger and goes, psst, see if it's hot. Well, this is the part of the iron which would be heated electrically. But if we had some sort of X-ray vision and could look inside, we would find out that the inside of the electric iron has a coil in it also. A coil which, when electricity is put through it, would heat. Now, we have the coil, and we've exposed the coil, so it'll be nice and easy to look at. Let's try plugging it in and finding out what happens. Again, I'm going to cover the top of the coil so that we don't have too much light reflecting from it by our lights right here. And I shall now plug it in. Let's watch the coil. Electricity is now flowing through the coil, and light is being given off. Unplug the coil. Let's see if there is a difference. No electricity, no source of heat, no light. Plug it in again. We find out that the inside of an iron, even though we don't see it, gives off light as well as heat. Now, Thomas Alva Edison knew of this, we call, phenomenon. Many other scientists knew about it too, but Edison really took the time and effort to do a tremendous amount of experimenting. And he said, he wondered if it was possible to produce light through heat and make this light bright enough that it could be used for illumination purposes. You know, bright enough so you can read newspapers and do other jobs around the house. Now, what Mr. Edison did was he took a piece of wire and arranged it so that when electricity was put through it, it would heat. The only trouble was that the wire kept burning. And he tried, I think, quite a few thousand kinds of wires, different substances to be used as a wire to be heated to give off light. Finally, it was discovered that if a glass cover were put over a certain type of wire and the air taken out of the cover, then when the wire was heated, it would give off light without burning. Because we do know that things cannot burn without the presence of air, or at least some of the gases that are in air. So that here we have taken a wire, or Mr. Edison took a wire, arranged it so electricity could go through it, heat it up without burning. This was the beginning of the first electric light. Now, in order to get a large wire like this into a small space, the wire was coiled, sort of like this. And this same size wire was allowed to be fit, see how it's coiled up? He fit this kind of wire into a small bulb. Now, I have a bulb here, quite an old bulb, and I'm going to plug it in with just a very small amount of electricity going through it. Now, let's allow only a trifle of electricity to go through. There we are, a small amount. Now, you notice how the shape of the wire inside of this bulb is similar to the coiled wire that I have. Now, this was very satisfactory for a period of time. Another thing that bothered Mr. Edison and other scientists was getting the wire closer together. So after a while, the idea of this coil being coiled this way was stretched out, and they took a very simple thing, like this pencil, and they coiled the wire into a spring-like affair. Now, here we have the exact same length of wire, and we'll just make our spring right here in a pencil. The exact same length of wire, coiled up nice and tight. Let's fit it all on here. And you can make the same kind of coil, right, in class to show that you can get a lot of wire in a small space. Now, here we have a coil of wire, where before we had a long piece. Mr. Edison and his associates took this wire and bent it into a U shape, and then put the U shape into a bulb, and we have something like this. There's a U-shaped filament as compared to, I'll bend this around, as compared to a U-shaped coil. Let me just get my hands out of the way and you can see the coil. U-shaped filament, U-shaped coil. So that we got the same amount of wire into a smaller area. Now the question is, what is the advantage of getting the same amount of wire into a smaller space? The advantage is that by compressing the amount of space taken up by the wire, we can get better light. Not only better light, but more light. Because the light itself will be concentrated. Now these two bulbs, this bulb here, and the other bulb that I have, this one, and the bulb over here, both consume the same amount of electricity. One has a compressed wire inside, the other has the wire that goes up and down. Now what I've done is I've covered the two bulbs with this piece of paper. And I'm going to turn the brightness way up on our bulbs. Here we have a little control here. What I'm going to do is measure the amount of light given off by each of the two bulbs. In order to measure the amount of light, I've used a light meter. Simple piece of equipment. I shouldn't say simple, but a piece of equipment which your father might use as his camera. Let's see how much light is given off by this first bulb. You just shield it, and there we see the uncoiled wire bulb gives us, about 125. Now let's just slide along and get over to the bulb which has the coil. And there we find it gives us almost 250. Now almost twice as much light being given out by the coiled filament as compared to the uncoiled filament. Now the same idea was continued. If a small coiled horseshoe filament would give us a lot of light, how about making the coil even smaller and getting the light even more compressed? So what the bulb people have done, they have taken and compressed this coil into a very tight coil, placed it in a bulb, and here we have a bulb which has a single coil within it. And if we look very carefully and very closely at this coil, we can really see that it's a coil. Now I'm going to plug this light in and make it just ever so bright. And let's see if we can really examine the coil within the bulb. Now there we have, you notice it is a straight line, and this is really a spring of wire which goes straight, directly across the filament. Now this is the modern type bulb. Now we've seen how the bulb has gotten from little piece of wire heated by a torch right to the modern everyday filament. Now the question is, have we proved anything? Yes, we proved something that occurs in our review. We proved the first thing, that electricity can produce heat. And the second thing that we have proved is that electricity can produce light. We've done it here, and of course you back in the classroom will do the same thing. Next time we get together, we're going to try to see how a coil of wire, I have them right over here, a coil of wire, a compass, and a magnet can produce electricity. Bye now.